Come back to Technology Innovation Hub. It's going to be the 19th session on Oracle database architectural journey. Let me share the screen. It's going to be one of the most important memory structures and most demanded explanations that the industry needed. That is redo log buffer. Redo log buffer. So let's try to understand, as we have completed large full explanation on the previous session. Let's try to understand redo log buffer. As you can see, the redo log buffer is a circular buffer in the SGA that stores redo entries describing changes made to database with DDL and DML. Yeah, now we have been talking about different algorithms that is used in certain memory structures. Mainly, we have discussed about LRU algorithm, that is registration use algorithm, which is valid for sharp pool and database buffer cache as well. So now we are talking about a new algorithm called circular buffer. Circular buffer. So that's the technique used by this redo log buffer. Now, as I said, you can see the redo log buffer is a circular buffer in the SGA. It stores redo entries describing changes made to the database. This is redo. This is not undo. In Oracle, we have the specific term called redo, where most of other databases having undo. Undo means rollback. Rollback before commit, you can roll it back. But in Oracle database architecture, we have another tracking system called redo, tracking for changes. A tracking system to track the changes that are made to the records in the database buffer cache. So it's like Oracle recording the data for 2 times. I mean, it's tracking it for 2 times. For example, now undo will take care, or rollback will take care of the old images. So it also maintain, if you update a transition from, let's say, salary from 1000 to 10,000, now the 1000 will be the old image for rollback purposes. So there's a tracking there as well. No? But redo is a different tracking system that also has 1000 and 10,000 both, but it is tracking only the change, not the full record, only the change. So it's like you can see it's double recording technique, Oracle double recording technique. But 2 different reasons, 2 different, I mean, very clearly we can differentiate the 2 reasons. Normally, the undo is for rollback purposes. Rollback purpose. The redo is for recovery purpose. So we will learn more detail about that one later. Undo is for rollback, redo is for recovery. Because Oracle's primary recovery mechanism depends on these redo entries. It goes to archives, and with backups, we know we can restore and recover. So that makes the Oracle database very robust and zero downtime, zero data loss. That mechanism also primarily initially depends on this redo mechanism. So let's talk about in detail. Now, having said that, yes, whatever changes, DDL, DML, whatever changes made to the database, objects will be tracked in redo log buffer in order to reconstruct them, or in case of a failure, likewise. So we can, and if you want further, we can analyze the redo log files as well to track the changes. So let's talk about those things later. Circular buffer, that is another thing. So let's try to understand circular buffer. Let's go to the picture because it explains that one clearly. Circular buffer you can see in the picture. So let's go into sharp pool. We know redo is a component in the SGA, system global layer. So there comes redo. Still we haven't touch upon this database buffer cache, but now we have explained the large pool and sharp pool. So now we are going to touch upon or explain redo log. And now you can see the circular buffer. Yeah, if I put it to full screen again, as you can see here, the circular buffer, even the animation I have put it in that way, so it circulates. So this is what I just want to show you. It rotates like that because now the server process. I think you can see in the picture, we know what is server process now on behalf of the client requests. All the things are processed via the server process. In dedicated server, one-to-one mapping is there for client and the database. In shared server, we have the shared server process. Records will be pushed to the data buffer cache via the server process as requested by end users. And similarly, the changes that are made to the records in the buffer cache will be tracked or will be updated to the redo log buffer by the server process. So this is what the picture indicates. Now, when server process is writing to the redo log buffer, it has to follow this circular algorithm. Now, circular algorithm means, say for example, now if you take this particular block in a given situation, this particular block, it can be updated by the server process. At the moment, there's an ongoing update happening for this given block, maybe one or two. Let's say these four blocks have been updated by the server process. Now, in the meantime, the records from the redo log buffer, can be written to the redo log file via log writer. That is what. Two payloads are actually working. One is server process writing into the redo log buffer. Log writer reading from the redo log buffer. So both payloads are busy here. Log writer process are reading, this payload is writing. Now we can't have any conflicts here. So that's why it's a circular buffer. So while while the server process is updating this area in the redo log buffer, the log writer can read from the remaining area, because there are conditions for log writer to update the data from redo log buffer to redo log file. We will talk about that one later. For the time being, a commit is a one condition, log writer. So when a commit happens, log writer has to read from here and update here. In the meantime, other people are issuing updates and changes are happening to the records in the data buffer cache now. So therefore, the server process should be able to write to the remaining portion of the redo log buffer. So it circulates, it rotates like this. This payload server process keep on updating this segment, and this payload keep on writing. So once the writing finish, this part get finished. So the server process again can continue to the rest of it. And this likewise, here again is log writer reading from this area and clearing. Again, server process is going. So likewise, it gets circulates like this, it rotates. So that's the behavior of a circular buffer. But anyway, we can discuss it more in detail, the way the circular buffer exactly in more detail with under tuning memory structure. So we'll discuss that. But I think for the time being, you got the idea, the circular buffer. So that is a different logic it is used. Circular buffer is using a different logic. Right, that's the logic behind the redo log buffer. If you continue the explanation, now this is what's going to happen now. The updates requests are coming via the server process, and those records should be fetched initially the server process from the data files. The relevant records should be fetched to the buffer cache, and those records are going to get changed due to the update. So redo log buffer will track those changes, and finally, depending on the conditions, log writer has to update the data from redo log buffer to the redo log file. Because redo log buffer is a small size and we don't have that much of size. Maximum, maybe this is an MBs. Redo log buffer, like the data buffer cache, we don't go for gigabytes. Not necessary at all. Maybe 20 MB, 10 MB likewise. So we don't have in GBs. Redo log buffer, we don't set in GBs. Small size, but there are conditions. As I mentioned, commit is one condition for log writer to write data to the redo log file. And for example, when 1 MB of full, if the redo log buffer is full 1 MB of data out of, let's say if there are 6 MB, now 1 MB is full, then that becomes a condition for log writer to write data from the redo log buffer to redo log file. Then there are conditions like 1/3 full. So let's go to those conditions in more detail. And in the practical side, so let's take a look at the redo log buffer. This is how we can take a look at it. If you just type the parameters, show parameter like the other memory structure, this also there's a parameter. Just type log underscore buffer. So this is what you can see. It is in KB. The value is being set from KB. This is the current value in my case. So if you want to get more details there, so we can just, let's check the parameter. Now this is 12, that's fine. So log buffer, default value 5 MB or 32 MB depends on the GA size and CPU count. Yes, let's do a separate explanation on that, how this sizing can be done for the log buffer. And the default, it says 5 MB to 32 MB. From 5 MB to 32 MB, I think in my case 7 MB was there. 7000 K, some other value is that. Yeah, this is 7 MB, and it varies from, as you can see, 5 MB to 7 MB. That's what it says, depending on the SGA and the CPU count. Yeah, the value, there's a way to take this value if you want to set a value, but normally we don't adjust the value, so let the default be there. But if you want to set the value under tuning, we can do it. So range of values 2 MB and like as operating system dependent. Anyway, about setting the value for this parameter, we will have a separate discussion, but I just want to give you the indication what is the parameter. So if you want to set the value for the parameter, this is the parameter log buffer. So let's have the theoretical explanation first, a little bit detailed. Now that is that, and yeah, the circular buffer, it goes in that way. Then log writer writes. Now when log writer writes, it writes to the current log file, because the file which is in use at the moment, it is known as the current log file. So normally in a database, we should have minimum 2 log groups. Group in and files are two different things. So let's discuss those in more detail later. But minimum 2, recommended 3. But actually recommended 3. You can't operate it 2 log files or groups because there can be issues. Recommended 3. So at least 3 has to be there. But you can increase, depends on the environment. We are telling it as a thread. We do thread. Now in example, my case here, I have 3 log files. So my thread, in my redo thread is whole set of files. We can take entire 3 files as a one thread. That is how the thread is working in Oracle database. So in my thread, I am having 3 files. And the current file is the one which is the log writer is writing in at the moment. So if you want to see this one again practically, we can say describe $log. And if you take a look at this one, in my case, I have the group, let's say, and we can take a look at the thread. Thread will be always 1 because I have only one thread. I have only 3 files in this system. And we can take the status from $log. So you can see at the moment my current file is number 3. You can see thread is always 1. So in a normal environment with a single instance environment, thread becomes always 1, because here I am running a standalone database, so I don't have a cluster here. So in a standalone environment, there's only one thread. Thread is entire set of log files or groups that you are having. But in a clustered environment, when you have multiple instances, each instance will represent a thread. That's why. Let's say you have 3 instances in a cluster environment, instance 1, instance 2, instance 3. So instance 1 will be your thread 1, instance 2 will be your thread 2, instance 3 will be your thread 3, likewise. So let's understand those things in detail later. At the moment it is this. If I want to get the members, I mean, now I have 3 groups now. So let's we can describe log file for that. And if I just type select again group, comma, we can take member from log file. So you can see I have 1, 2, 3. In my group, each group having only 1 member. It is not multiplex. So again, we will discuss about multiplexing, because Under Oracle database physical architecture, we have a separate chapter, separate discussion, which is supposed to be done later. In that, we will be discussing more detail about little of groups and how this switching and these things are happening. But for the time being, only for the architectural level explanation, I am not going to that much of detail on this physical structure side. But for you to understand, you can see I have 3 files here. Even though I have say groups, in the group I am having only one member. Normally, when you group in, we need to multiplex them. So multiplexing means we should have more than one member in the group. So I am having, so at the moment my current is number 3, that is redo member 3. This is my current log file. That is fine. When it comes to grouping, it should be like this. I can just show you a document like this. So this is just to get an idea about the time being, since we are talking about individual log files and groupings. When it become groups, it's like this. This is multiplexing. You can see U01, U02, U03. Now U01 is a mount point. U02, U03, all are 3 mount points. This is group 1. This is member. Each member is located in a different mount point. You can see here now this is group 1 and member 1 of the group. Group 1, member 2, group 1, member 3. So there are 3 members in the group. You can see that. And group 1, member 1, member 2, member 3. And this is group 2, again member 1, member 2, member 3. And group 3, member 1, member 2, member 3, likewise. Now this is multiplexing, but actually multiplexing means, now here is indicates the mount points, no, but on the behind, I mean on the back side of the infrastructure, these mount points should be physically distributed across multiple disks. So that's what exactly multiplexing is. Now, for example, if you have only 2 disks, let's say there's only 1 disk, so you can partition and create mount points, no, but that is not the real meaning of multiplexing. When it comes to multiplexing, each member must locate in a physical disk. That is multiplexing. On the back end, now let's say if you have a SAN or NFS file system or whatever, you need to make sure your system administrator has been, he is configuring the mount points by distributing across multiple disk units on the back end. So that is something as a database administrator you have to make sure. Otherwise, the one purpose of multiplexing is what? To avoid failures. To avoid failures, this is a high availability technique. Why we multiplex? That is for to facilitate high availability. Normally we multiplex control files as well. So it is highly recommended in a production environment to multiplex. So that's the theory behind it. You can see now this is a grouping system, multiplex distributed across multiple mount points or multiple disk units. And in that case, group 1 is member 1 in group 1, member 1 in group 2 located in this particular disk series and this system, we can say, for mount point, and this is located in this 2 mount point and 3. So on the back end, yeah, it must be distributed across multiple disk units. So that is grouping. In terms of grouping, when Oracle updating, Oracle means when log writer writing into the log files, it will treat the whole group as a one file. That is how it works. Log writer will treat the whole group as a file. That is how. Now, if you go down, now this is not multiple, this is individual files. You can see redo 1 and redo 2 and redo 3. So that means redo file is for log writer, redo 1 is equal to the whole group, group 1. So this is for you to get an idea. I just show you, but we will discuss more detail. How to configure and creating grouping and those things will be done in the later chapter under physical structure. For the time being, just get an idea. Now, in my case also, in the presentation as well, I have taken individual files, so that's okay. For the log writer, whether it's file or group is the same thing, because what he's doing for the available group or the file, he'll be writing parallelly. Parallel means if it is an individual file, there is no parallelism required, only one writing. But in case of group, you may have 3 files. For the all 3 files, he will write parallelly, log writer. So that is how it's going to work. So current file, as we noted in the hands-on the practical earlier, that is where it writes at the moment. Currently updating current file. Fine. So let's continue a little bit. Now, this is what happens. After a certain period of time, your current file will get filled. That means now log writer keep on writing to this one. It will get filled, and that means it will run out of space, because normally these files are maybe default, the default size is 100 MB. We can say like that, 100 or 50 MB. You can take a look at it, but it is not always recommended, because the redo log file sizing is a separate thing that you need to discuss under optimized redo log files. We need to set the optimal log file size. It depends on your business nature. Database to database, it can change. We never keep the default log files. Keeping the default log file sizes will definitely cause tuning issues for database, and we will discuss those things also under tuning, how to set the optimal log file size. But let's assume currently the default size is 50 MB. Now 50 MB is filled. Is running out of space because this fellow keep on updating here. So current file will get filled. So once that file get filled, what's going to happen? Oracle will do something called a log switch. It will jump to the next available file. Now we have 3 files now. So in the group, it will jump to the next group. So this operation is known as a log switch. Log switch. Finishing the previous file, starting the next file is known as a log switch. Now when a log switch happens, what's going to happen? There's something called a checkpoint take place. This is known as a log switch checkpoint. Log switch checkpoint. Because in Oracle database, we have different categories of checkpoints. We have incremental checkpoints, full checkpoints, and partial checkpoints. We can take those 3 categories: incremental checkpoints, partial checkpoints, full checkpoint. Now, incremental checkpoint and log checkpoints are most of the cases same. Incremental and log switch checkpoints are same now. So here what's happening is a log switch checkpoint or a incremental checkpoint. So we will understand what we mean by log switch checkpoint in the next coming slide. So I have a separate explanation for checkpoint. So in that we will understand more detail. For the time being, just make a notice: each log switch there will be a checkpoint. And then what's going to happen? And this fellow get filled, and the cycle goes to the next one. So as it fills, it jumps to the next one. So now this fellow, when with the log switch, this fellow becomes current. Now earlier this one is current now, and this fellow becomes current now. And the next one, once this one fills, next one becomes current. Again there will be checkpoint happening and log switch. And once now the cycle, the last one comes. So once that one fails, what's going to happen? This another log switch. Yes, true. Now with this log switch, there is no further log files available as per this. Only 3 files are available. It should go and overwrite. It should go and overwrite. Overwrite the first one. But you can't just go and overwrite. Why? In between, Oracle will allow, I mean, whether the incremental checkpoint is completed or not, it will allow to do the log switch and continue to write to the next one. But when it's overwrites, checkpoint should be completed. Checkpoint should have been completed. That's the case. Because without completing the checkpoint, Oracle doesn't allow, because we know earlier I mentioned at commit, Oracle or the log writer will update the redo log files, not the data files. At commit, Oracle will not update the data files. So all committed data is available in the redo log file. Now at checkpoint only, Oracle will gradually synchronize the data files with the latest committed data. We will understand that one later. At checkpoint only, Oracle will synchronize the data files with the latest committed information. This is very important to understand, but I'll be explaining repeatedly in the upcoming sessions as well. So therefore, Oracle cannot overwrite the committed data which is in this file till checkpoint go and inform the data files, okay, or the checkpoint go and synchronize the data files with the committed data. So that has to happen. So that's why checkpoint should have been completed. Otherwise, it will not allow to overwrite. Right? So that's just to phase 1 of the explanation, just to get an idea what is redo log buffer and how the mechanism is going to work. Fine. So with that, let me end this session here. Otherwise, from a single session, we can't be covering everything. So up next, we will try to do a hands-on about the sizing of the redo log buffer as well, and we will continue to explain this checkpoint mechanism as well a bit. Fine. So I will meet you soon in the next session. Have a great time. Bye-bye.